Lakes Indian Fish and Wildlife Commission, and I was asked to speak today a little bit about contaminants in fish in Lake Superior. And since this can be pretty complex, I'm going to try to stick today to just some of the main trends that we're seeing in the lake and back it up with a couple examples for each. Starting out with my acknowledgements, in particular I want to point out the one in the middle. So a lot of the data that I'm going to show today was collected in the long-term monitoring programs of the EPA and Environment Canada. Beth Murphy did a lot of the analysis and actually provided a lot of the charts that I'll be showing today. So to put this into some context, there's two kind of lake-wide goals that I wanted to mention that relate to contaminants. The first is the fish community objective, the habitat community, and the part that relates to contaminants is underlined here, and that's to the goal to reduce contaminants so that all fish are safe to eat. Another lake-wide program that's going on is the Zero Discharge Demonstration Program that's part of the Lake Superior Binational Program. And as you can see, the goal here is to try to achieve zero discharge or emissions of 9 particular contaminants from emissions from within the Lake Superior Basin. And this project started in 1990, and it's reported out on the progress every 5 years. This is an older, cover, but we actually put out the 2010 report this past November, and these are available online. So there's a number of long-term monitoring studies for contaminants that are going on in the Great Lakes and in Lake Superior in particular, including the abiotic matrices such as air, water, and sediment, but biota as well. So there's studies of contaminants in herring gull eggs, there's work being done in bald eagles, and the one I'm going to focus on today is lake trout. These are the main fish species that's used to track contaminants in the Great Lakes, except you'll see on some of my plots walleyes generally used in Lake Erie just due to the low lake trout populations in that lake. So I'll focus on lake trout. The reason they're used, as you know, they tend to be at or near the top of the food web, and they're long-lived, so in essence they can integrate all the contaminants in the food web below them, so they're great to look at. They're also obviously important subsistence, commercial, and sport fish species. I already mentioned this Zero Discharge Demonstration Program. I just wanted to touch on emissions before I get to levels and trends. So what you see here is the reduction schedule for the ZDDP. In other words, relative to 1990 baseline levels, the hope is to reduce emissions by these various levels for each contaminant with total elimination by 2020. And for the most part, we put out our 2010 analysis. We've been very successful. This applies just to the 9 contaminants you see here, legacy contaminants. One example of this is mercury. So the goal was to have mercury emissions from within the Lake Superior Basin reduced by 80% by 2010, and we just met that goal. The plot shows the goal relative to the actual levels every 5 years, and this represents a 29% reduction in the last reporting period, 2005 to 2010. One thing to note is that it's going to become progressively harder as we approach this zero or virtual elimination to keep reducing these contaminant emissions. And just in case you're curious where the mercury is coming from within the basin, it's about 63% in 2010. The purple bars are coming from the mining and metals production industry, followed by about a quarter coming from fuel consumption. Everything else in 2010 is about 3% or less. So this is different from the national trends where coal-fired power plants and fuel would be the highest emitters of mercury. So moving on to levels and trends in fish, which is probably what you're most interested in. There's a few trends that we see. You might hear that Lake Superior is pristine or one of the cleanest of the Great Lakes, and this is often the case due to the fact that there's a lower population, there's less development here, and because of programs like the Zero Discharge Demonstration Program. For example, what you see here is data from the EPA and Environment Canada looking at PCBs over about 30 years. And Lake Superior is here in the upper left. And what you see is that Lake Superior lake trout have had lower PCB levels than lake trout from the other Great Lakes. And you see a similar pattern for a lot of other of these older legacy contaminants like dieldrin, DDT, and chloridane. But this is not always the case. Lake Superior isn't always the cleanest lake in terms of contaminants. A lot of it's due to the lake itself being colder and larger than the other Great Lakes, but we also do, even though development's left, still have local pollution sources here. So 2 examples of contaminants that tend to be higher in Lake Superior in the fish are mercury and toxaphene. So here, the points for Lake Superior are circled in red, and this is showing levels of mercury in lake trout and walleye. The top are the 1980s, the bottom is in 2007. And the point here is just to note that the point for Lake Superior is consistently over time higher, meaning there tends to be higher mercury in lake trout from Lake Superior. Similarly with toxaphene, if you look at the chart at the top here for Lake Superior, in the time period 2005 to 2009, the concentrations were higher for lake trout. And the good news, though, if you look at the bottom, is that even though it's higher in Lake Superior, over time there's been a steady decline in toxaphene concentrations in lake trout. Many of the legacy, the older contaminants, the ones that have regulations behind them, are decreasing in the environment and in fish, in part due to regulations such as the Clean Air and Water Acts and the work of the Stockholm Convention. Here's an example. We already saw PCBs, but now talking about the time trend in lake trout and Lake Superior, there's been about a 5% decline per year in PCBs and lake trout over the last 30 years. We see similar declines, about 7% per year in DDT, steady declines in chloridane, which now seems to have kind of leveled out, and declines in dieldrin as well. This is complicated, but the point here, all the top graphs are the Keweenaw Point sampling location for lake trout, and the bottom are the Apostle Islands, and you have various contaminants across from left to right. And I just want you to know, every plot that shows a line means it's a statistically significant trend, and they're all decreasing over time for these contaminants. One notable exception is mercury. There's now enough data to see that it appears that there's been a tipping point. Mercury has declined overall since the 70s, but it appears that around 1990, according to the EPA and Environment Canada data, that there actually now is an increasing trend in mercury in lake trout and Lake Superior. It's not really known why. There's a lot of theories having to do with climate change, changes in the food web, invasive species, changes in growth rates, and people are really just trying to it wasn't until the last couple of years that there was enough time trend data to even know that this was going on. So we have a lot of these, I've mentioned these legacy contaminants, they're declining, but at the same time, there's a lot of new contaminants we call emerging contaminants of concern that are on the rise. One example are polybrominated diphenyl ethers. And these increased exponentially through about 2000, and then in response to bans on these compounds, there's been a decrease since 2000, although it's not statistically significant. It's a pretty apparent decline, and it appears that it's now leveling off. There's a lot of other contaminants that are presumably still increasing, are currently increasing in Lake Superior fish, but because they're new, we've just learned how to detect them. We don't have the time trend data to show pretty plots like this that show what they've been doing. Some other of the newer contaminants that are being looked at now are things like pharmaceuticals, personal care products, perfluorinated compounds, synthetic musks. Even though we see a lot of decreases in contaminants, especially these older legacy contaminants, many contaminants still exceed levels of concern. So this would include things like not meeting the fish community objective of having all fish safe to eat. There's threats to both human consumers, but also fish eating wildlife, and in some cases, threats to the fish themselves. So this, the Ontario Ministry of the Environment's Guide to Eating Ontario Sport Fish for the current year is a 337-page document, and I just put that up there to show how complex this can be with different contaminants, different species, locations, different size classes of fish. The pie chart on the bottom shows what contaminants are driving the consumption advisories in this document, and you can see it's about 3/4 are PCBs, followed by mercury, toxaphene, dioxin, and furans. If you were to look at a pie chart like this for inland lakes, it would be flipped with mercury being the largest driver of consumption advisories. Not a lot of time, so I won't go into this, but this was just to show the consumption advice for Lake Superior put out by the state of Michigan, just to show that it's not just on the Canadian side that there's complex advice, that it's nearly every species has some suggested limitation on consumption, even for species like whitefish across the bottom here that we typically think of as being fairly low in contaminants. Again, it's not just a risk to human consumers, but to fish-eating wildlife as well. So what you see here are levels of PCBs in whole lake trout as of 2005 in the different Great Lakes. And even though they're lowest in Lake Superior, it still well exceeds the EPA's established fish-eating wildlife protection threshold of 0.16 parts per million. So just to sum up, Lake Superior is often lowest in contaminants, including in the fish, but this is not always the case, such as with mercury and toxaphene. Many legacy contaminants are declining in response to regulations, but there are emerging contaminants of concern that are on the rise, and some of these chemicals, even that are on the decline, are continuing to exceed levels of concern. And with that, if there's time, I can take questions.